Hello again to your channel, Math Made Easy. Um, so now we are done with the basics of probability. Sometimes in probability, you need to learn how to count. I'm waiting for your response. No, yeah, you count on your fingers. If you can, just count on me. I'll let you know what we are talking about. Counting techniques, meaning we are going to count stuff fast in probability. You know that if I want to know the probability of some event, and this event is what we call discrete, meaning you can count it. Let's say, just again, rolling a die. You know there are six outcomes, right? So if I tell you what is the likelihood that you get three, you say three, I can get only one out of six. So that's easy. And but what I want you to understand is that the underlying thing in which allows you to say one out of six is that all the outcomes are equally likely to happen. Okay, it's not a loaded die. I'm not trying to cheat you in a gambling game, or it's not like a biased coin. No, we are saying that the playground is the field ground is plain and it's equal for everybody. So the probability of getting every single outcome is equally likely. In which case, I need to know how many possible outcomes are there in the sample space and how many outcomes are in my event. And I will divide them, right? Like one out of three. If I say, what is the probability that you get an even number? You say two, four, six. They are three out of six, so one half. And of course, you don't need even to do that. But what I'm saying is we need to learn how to count. And you say, but it's easy. Yeah, but sometimes it's not known. For example, let's take an example. Suppose you are going to have elections in a classroom to form a committee or to form a team that will play against another team and so on and so forth. You want to make a committee out of students, and just for simplicity, you are going to take very small number. Let's say you have 5 students who want to run for office, and you have 2 or 3 offices. You can have a president for the committee that we are going to uh, elect. We can have a vice president, and maybe you can have a treasurer or a secretary. Let's say treasurer. In how many possible ways can you select the 3 students if you are randomly selecting them? So they are not running and making, statements or whatever. No, we are going to have like 5 names in a ball, and we would select one at random. The first one selected would be president, the second would be vice president, and the third would be treasurer. Okay, so we need to know how many possibilities. I'm going to use PVT for these students: 1, 2, 3, 4, and 5. Let's count how many ways. In fact, let's take away the treasure, because the counting here would be, we'll do it in the next thing. But here I can have P and V, or P and V, or P and V, or P and V, right? Or I can have P and V, P and V, P and V, P and V. Or I can have the president is number 3. So V, or V, or V, or V. And then I can have the president here and V, P and V, P and V, P and V. And finally, I can have the president here and V, president, vice president, president, vice president, president, vice president, for a total of 20. But you see what happened when the president, when you said if the first student is a president, how many possible ways I can get a vice president? Of course, it would be the second, the third, the fourth, or the fifth. So they are four. But what's the difference if the president is the second student? Then you can have four ways you can select a vice president: the first, the third, the fourth, and the fifth. Four, 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 four. So 1, 2, 3, 4, 5 times 4. 5 times 4 is 20. So there are 20 ways. Suppose we had a treasurer as number three. That in the beginning I was doing something else, but you know what we will end up having? For every combination here of P and V, you can have the treasurer be 3, 4, or 5, right? Here it would be 2, 3, or 5. Here it would be 2, 4, or 5, or 2, 3, and 4. Here it's 2, 3, and so on and so forth. So it's like for every combination, you have three ways because you already selected two spaces out of five. So there are three remaining. You can place the treasurer here, here, or there. So it would be 5 times 4 times 3 for a total of 60. I wouldn't have enough space, and so on and so forth. So we developed something we call the permutations. So what is a permutation? A permutation is a selection of objects. Usually we write it as permutation k out of n, or some people write the n here and the k here. It's the same thing. Meaning I'm going to select k objects out of n possible objects, and the order is important. What do you mean order is? Yeah, you see, if I select the first name as student number one, he or she would become president. So the order of selection is important, right? The name I would select would be president. So the order is important. Order is important. And we say, how do we calculate that? You take the number of elements, which is n, and take the factorial of n, like n times n minus 1 times n minus 2 times 3 times 2 times 1, depending on what n is. And you divide it by n minus k factorial. So let's apply it here. We have 5 students, so 5 factorial. And we have 2 students, so divided by 5 minus 2 factorial equals 5 factorial over 3 factorial equals 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. And sure enough, these would simplify and you get 20 as we counted. So you don't need to count. Suppose this was 10 and that was 4. So you would multiply 10 times. And then you see, wait a second. In fact, I can think of it slightly differently. Instead of writing the whole thing and keep simplifying, I can say, okay, they are 5 and you are selecting 2. So you start counting. 5 is the first digit times 4. I already have 2, so it's 5 times 4. Do you understand what I'm saying? Suppose I want to select 4 out of 7, and the order is important. I either can say the 7 factorial over 3 factorial, or I can say it's 7, that's 1, times 6, that's 2, times 5, that's 3, times 4, that's 4. I reach 4, so I stop. I didn't mean the number 4. I said 4 elements. Okay, and you solve that, so 2120, 840, and that would be the answer. And so on and so forth. Let's take another one. 3 out of 8, so we don't end up with the same number. 8, that's 1. 7, that's 2. 6, that's 3. I stop, and that's the answer. So you get 56 times 6, 336. Okay? So that's the permutation. You are selecting k objects out of n, and the count and the order is important. Okay, someone would say, what if I'm selecting n objects or k objects out of n, but the order is not important, meaning that you are going to tell, you select the best, say, math student from each class, and maybe you selected 10 of them, and you want to say, you know what? I'm going to take, or let's make it also a manageable number. So let's say you have 5 students. But this time you are going to say, I'm going to select, let's make it also 3, like before. No, 2 as before. I'm going to select 2 to come with me and represent the school in a math competition in the district. Is the order important? Absolutely not. I'm going to select 2. It doesn't matter. The first will not be the team captain and the no, they are both competing. So select 2, order is not important. Okay? So I want to find the number of ways we can select those. Okay? So we can say, since the order is not important, I can select 1 and 2. I'm not going to say and 2 or and 1. For example, here, when the order was important, P being the first selected and V is the second is different from P is the second and the V is the first. That's different. But here, I'm not going to say 2 and 1 because it's the same thing. Both of them are going to the game. 1 and 3, 1 and 4, 1 and 5. And then 2, I'm not going to say 2 and 1. I'm going to say 2 and 3, 2 and 4, 2 and 5. And then 3, I'm not going to say 3 and 1 or 3 and 2 because it's the same. I'm going to say 3 and 4 and 3 and 5. And when I go to 4, the 4 already happened with 1, with 2, with 3. So it's only 4 and 5. Do you see what I got? 4 times where 1 is selected, 3 times when 2 is selected, 2 times when 3 is selected, and 1 time when 4 is selected. Like 4 plus 3 plus 2 plus 1 is 10. There are 10 ways of doing that. Now, we call that a combination of 2 out of 5, and most likely we write it like 5 take 2. And the definition of C, K, and N is P, K, and N divided by K factorial. Remember what P, K, and N was? It was N factorial over N minus K factorial. And now I divide again by K factorial. And this becomes 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times, 3 times 2 times 1. So these cancel. And this over that is 2. 5 times 2 is 10. Of course, we don't do it like that. So how do we do it? We get the pKn, which we learn how to do it. So we say 5, that's 1 times 4. So that's, I had two numbers. So this is pKn. And then I divide it by 2, which is 2 factorial. So you get that. And now I'll go back to my beloved Pascal Triangle again. Yeah, you will see it again in this course. So I keep referring to it. It's, you know, It's my last resort. When I'm stuck, I go there. You see the row of five, the fives row, this guy? This number, you can think of it as 5 take 0. You say 5 take 0, what does that mean? It means you have five objects and you want to select none of them. In how many ways can you select none? You say none, so it's only once. I'm not going to select anything. So that's trivial. And this one, I can think of it as 5 take 5. You have five objects, you want to select all five. In how many possible ways can you select five if the order is not important? Remember, I'm going to select them all. So there's only one way. There are five ways you select 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, and 5 out of 5. So you see, 5 take 2 is 10, 10. So if I have that, I can find the combination of anything. If I have 10 objects and I want to select 4 of them and the order is not important, 1, 2, 3, 4, there are 210 ways to do that. It didn't take me a second if I have the table in front of me. So I can very easily find the combination, and that's if the order is not important, and it doesn't matter how many I'm selecting. In fact, your calculator can also do it in no time, but if you don't have a calculator, then Pascal Triangle to the rescue. So maybe we'll stop here because next time I will go and talk about something else that we may need it. You may need it next session or the one after that. So today we did the permutation when the order was important and the combination when the order wasn't important. And let's leave it here, easy, short, so that you get prepared for what's coming. Thanks for your time and hope you have a great day.